Hello my young friends, I am Naveen Sharma and I am going to help you in learning class 12th chemistry. So in the previous meeting we were discussing the factors affecting the solubility of gases in solution or in liquids. We have done two factors. Now we are moving on to the third factor, that is effect of pressure. Now how does the solubility of gases depends on pressure. Let us understood this with the help of an example. Suppose there is a liquid and gas, suppose carbon dioxide gas dissolved in it. If we apply pressure with the help of piston, if we apply pressure and we increase pressure, what will happen? Volume of gas decreases, but number of molecules remains same. So number of molecules per unit volume increases. Number of molecules per unit volume increases, hence more number of molecules will go into the solution, or we can say therefore solubility of gases increases on increasing pressure. Is that clear? So solubility of gases increases on increasing pressure, and this relation was given by a scientist called Henry, and we will study this under now the heading of Henry's law. Okay, so next topic will be Henry's law. In the effect of pressure only we have Henry's law. Now what does Henry's law states? Henry's law, it states solubility of a gas at a given temperature, is directly proportional to the pressure at which it is dissolved. Directly proportional to the pressure at which it is dissolved. Okay, so we can write mass of gas into the solution is directly proportional to the pressure. M is equal to Kp. K is the proportionality constant. K is called the proportionality constant. Okay, if suppose Xb mole fraction of gas is taken, as the measurement factor for the solubility of gas, in solution, then Henry's law statement changes as, so we have a new statement. And what is the new statement? New statement is the moles or the pressure of gas, over a solution in which over a solution in which it is dissolved is directly proportional to the mole fraction of the gas is directly proportional to the mole fraction of the gas in solution. Now, if in the exam it is asked what is Henry's law, so you have to write this statement. Okay, examiner are expecting this second statement. Okay, now, so the second statement says the amount of what is this second statement says the amount or the mole fraction of solute, that is gas here, is directly proportional to the partial pressure of the gas. That means more the number of molecules of gas present in the solution, then more will be their pressure. Okay, if there will be more number of particles or gases or the molecules of gases in the solution, then they will exert more pressure. What is P? P is the partial pressure of, what is P? P is the partial pressure of gas, means the pressure which gas exerts in solution. Okay, P is the partial pressure of gas. So, XB is directly proportional to pressure, or this statement can be written as pressure is directly proportional to XB. Directly, to put equality, we have to remove directly proportional sign by the factor or the proportionality factor KH. This KH is called Henry's law constant. This is called Henry's law constant. Henry's law constant. Is that clear? Okay. Now, what is the significance of KH? What is the significance of this Henry's law constant? First, its unit is same as pressure, that is bar or torr. Unit is same as pressure, that is torr or bar. Second significance is solubility of gas is inversely proportional. Solubility of gas is inversely proportional to this KH. Okay, so more the value of Henry's law constant, lesser will be the solubility of gas in it. Okay. Third, KH increases with increase in temperature. KH increases with increase in temperature. Okay, so and we already know when temperature increases, solubility of gas decreases. When temperature increases, solubility of gas decreases. Why? Because solubility of gas is an exothermic process. Solubility of gas is an exothermic process. We have discussed this in our previous classes. Okay. For example, solubility of gas N2 at 298 Kelvin, solubility of gas at 293 Kelvin and at 303 Kelvin. We have different values of KH. For nitrogen at 293 Kelvin and at 303 Kelvin. One is 76.48 bar, 76.48 bar and 88.64 bar. 88.64 bar. So you can see as the temperature increased, the value of KH also increased, but the solubility will decreases. Solubility will decrease here. Okay. Now I hope this much is clear to you. So this was the significance of KH. Now after the significance of KH, there are certain applications of Henry's law. Applications of Henry's law. First is the condition of bend. Now what is bend? Now you all know what are scuba divers. When scuba divers go into the river or ocean under the water, there is excess of pressure of water on their body. Now due to this excess of pressure, the amount of gas dissolve more in their blood. Now they carry the oxygen cylinder with them. Okay. Now in the oxygen cylinder, when they go into the water pressure on their body increases, and we all know when the pressure increases, the solubility of gas also increases, and so more amount of gas will be dissolved into the bloodstream. And when the scuba divers came out of the water, this gas which was earlier dissolved due to the excess pressure wants to come out of the blood, and it forms bubble inside the blood vessels. Why? Because now pressure has decreased. Earlier into the water pressure was high, that is why more number of gas molecule will go into the bloodstream, and when the scuba diver come out of the water, this pressure which was earlier dissolved under excess pressure, now due to decrease in pressure wants to come out, and they forms bubble inside the bloodstream or blood vessels, and this causes pain, and this painful condition is called bend. Is that clear to all of you? This painful condition is called bend, and sometimes this pain is so severe then even deaths can occur. So in order to minimize bend, now what scuba divers do, in order to minimize bend, scuba divers have to have helium gas dissolved in their kit, in their breathing kits. Okay. Now what is why they want this helium gas? We all know helium has low molecular mass, so the solubility of helium is also very low even under high pressure. So even under high pressure, little amount of helium will go into the bloodstream, and when scuba diver come out of the water, when pressure decreases on their body, not much amount of bubbles will form into the bloodstream, thus they can minimize the condition of bend. Clear? Okay. So due to the knowledge of Henry's law only, that when pressure increases the solubility of gases decreases, we are able to minimize or use this here to minimize the condition of bend. Okay. Now we will discuss the second application in lungs. In lungs, O2, oxygen gas present in inhaled air. In lungs, what happen? O2 present in inhaled air. Okay. Now, when this oxygen is absorbed by a blood vessel, when this oxygen is absorbed by blood vessel, so there will be oxygen present in blood now, and when this blood vessel reaches the cells where oxygen is low, okay, partial pressure of oxygen is low but CO2 is there, what happen? There is exchange of gases occur. From cell, blood vessel receives CO2, because here the partial pressure of CO2 gas is more. Here partial pressure of CO2 gas is more, and here partial pressure of O2 is more. So from high pressure to low pressure movement occur, thus exchange of gases is facilitated. Okay, clear? So this is also due to the pressure difference. Okay, thank you so much.